Good morning, everyone. Welcome back to Netgear's SMB webinar series. Today, we will be talking about deploying 5 times faster networks using your existing cabling with multi-gigabit. We have joining us Xavi and Laurent, both from remote locations, and they have prepared a wonderful presentation for you guys. Remember, if you have any questions during the presentation, go ahead and enter them in the chat or the Q&A, and we'll try to get to you during the presentation. All right, take it away.
Thank you so much, Rachel. So this is Xavi. I am the PLM for Unmanaged Switches here in Barcelona. And with me is Laurent, well, with me in Paris. So Laurent, just introduce yourself.
Thank you, Xavi. Thank you, Rachel. This is Laurent Mazia. I'm talking from the Netgear French office. I'm the PLM for smart and managed switches. Really appreciate the time today. And thank you, Xavi and Rachel, for inviting me.
That's great. So guys, we are gonna start to cover this webinar. So the first thing is about the network. So we are gonna cover how to deploy 5 times faster networks using the same cabling as you guys have right now. So the topics for today, the agenda that we are gonna follow is first, we are gonna cover the design piece of the network. So what are the different networks that we can build? What are the challenges when we build the network? Second one is we are going to cover this new technology that's called multi-gig. That if I am right, Laurent, we were like the first vendor to introduce the multi-gig on the SMB space.
Yeah, almost the first. We were part of this N-based alliance, and 2 years ago, we were actually the first vendor delivering a 8-port multi-gig with 10 uplink called the M4200. That was the first one in the world of its kind. But to make it fair, other members of that N-based alliance came later on, with some bigger switches. But you're right, we were actually precursor with N-based 2 years ago. Now it's a standard. It's 802.3 busy, so that's a good news.
Wow, great. So we will cover this in depth. And yeah, we will talk also about the ecosystem, because that's also important, is to know what kind of devices we can connect to these fantastic multi-gig, 10-gig systems and anything that's beyond 1 gigabit per second. We will talk about some products that we have that supports this 10-gig and multi-gig technology, and we are gonna finish with a Q&A session, so you guys are gonna be able to ask anything else. So don't be shy, just make sure that you ask any question. So before we start, we would like to ask you guys, to the audience, what do you guys think that's the main bottleneck? Why do you guys think that we really need to go 5 times faster in our network? So if we can just get the survey for us, Rachel, would be great.
Give me one moment. Technical difficulty.
No worries. So yeah, guys, like the 1 gigabit deployments has been there like for a while. I think that we started seeing like the first gigabit deployments even like 15 years ago, or even like before than that. Yeah, even before 2000. So yeah, for more than 20 years almost, we've been like deploying gigabit networks. So yeah, it seems that we already reached the maximum speed of these networks, and we really want to move further. So yeah, from you, Laurent, maybe you can also give us an introduction in terms of the when you started seeing the first gigabit and the 10 gigabit products out there.
So I'm probably getting too old. I don't really recall for the 1 gig. I would say 96, 98 would be the very first switch in shipping, and Netgear Netgear shipped the very first 1 gig switches back in '99. This I know for sure. Now, to answer your question for 10 gig, we got the ratification at the IEEE back in 2003. It took us a few number of years at Netgear before shipping one SMB 10 gig switch. It was back in 2009. But yes, you're right. 1 gig is actually 20-year-old now, and 10 gig is actually almost 14 years old. So that's time, for something new. And we probably reached kind of a bottleneck with 1 gig big time.
Wow, you are totally right. So it seems that we're gonna leave the pool for later on. No worries, guys. Be there. So that's gonna be like, maybe we will leave it like us at the end of the webinar. So please be tuned on it. So we're gonna start for the design part in this case, and getting a little bit more information about what is currently happening. So if we just like get a zoom in into our computer, what we can see here is the different speeds that we are gonna find out. And as you can see, it's a really colorful web diagram. Everything looks green. You see like the CPU, the RAM, the PCI bus, everything except the network side of it. The network is on the red side. So what does it mean is that if we now look the any of our computers or any of our systems, because anything, it's mainly like design, as we can see here in this diagram. What we can see is that everything is faster than 1 gig. Everything is already faster than 10 gig or close to 10 gig. So if we look like, for example, USB ones, for example, we're talking about 10 gigs already, or over 10 gigs. And when we talk about the hard drives, for example, Laurent, do you have like a new SSD on your laptop, for example?
Yes, luckily enough, I have a SSD drive, but I don't think I have the latest and greatest, super fast new technology though.
Okay, well, but yeah, that's even like with the first ones, we already are over the 1 gigabit per second. So that's the good news for the SSD. So what it used to be the main bottleneck of the computers, it used to be the hard drive. You remember, like I still remember like these flashing lights on my computer trying to access to the hard drive. That was really painful. I am sure that you, Laurent, with your Excel files, you also get like some of these blinking hard drive ones.
Oh yeah, that's right. Especially for the big database, and big files, we used to wait for some time, and still today we have to wait. But you're right, SSDs are much faster. Now we look at the 1 gig NIC card blinking, right?
Exactly right. Yeah, we can have like, yeah, how crazy they are. Like when you do like a file transfer or a 4K video streaming or whatever, yeah, it looks like they become like kind of in a craziness area. Like all the flashlights on the switch and on the network interface are just like getting crazy. So if we look the picture, what we really want to highlight here for you guys is that, yeah, really, where is the bottleneck is the network size. So the 1 gigabit is not fast enough. And think about it, anything that you have in your area, it's faster than 1 gigabit. Wi-Fi right now, we are achieving like more than 1 gigabit. It's almost like 2 gigabit per second speed. So it's faster than the wired side. With the USB, it's the same thing. The RAM technology, the memory, it's also faster. So everything is really faster than the 1 gigabit per second. So when we're doing a file transfer, for example, what is limiting right now our file transfer, if I have a hardwired connection, is the network itself. So that's what we really want to avoid. So let's move on the next slide. So what we really want to do right now with Laurent and myself here, we want really to explain it to you guys what are the main bottlenecks of this network. And if the picture that we show wasn't that bad, we are now gonna see like even a worst case scenario. So for your point of view, Laurent, is that a common topology that you see in some of the customers?
Oh, I mean, we see much worse than that very often. So in usually, especially when it comes to small and medium businesses, we very often see, you know, switches that are daisy chained, but switches on switches on switches on other switches, that's a very long daisy chain. So you're right. I mean, that's even worse at every hop, right?
Yeah, so what's just as a curiosity, I remember once when I was like going to, it was in a university in this case, and I remember they were like, it was a 10th floor building, and what they did is that they put like a switch on the basement, and each floor was linked to the other one. So imagine the one that was like in the top floor, to get something, like to get to internet, they need to go through all the different floors. So yeah, that was really, really bad. You're right. Like you can see like even worse the scenarios, like two switch cascade is kind of like the, to be honest, is the minimum or like still like kind of like a good one.
So Xavi, maybe we should make sure at this point that all our attendants are comfortable with the oversubscription ratio that you display here, 24:1. So what does it mean, 24:1 in that case?
Yeah, no, you're absolutely right. So here we really want to highlight when we do a network design, what are the main bottlenecks. So like what it does mean, this one is that here we are talking about 24 port switches here. Okay, so all of these switches are 24 port to make it simple. So what does it mean, this 24:1 oversubscription rate? Is that in this case we have 24 port switches, but all of them, if they need to talk to the core, where we have the servers, where we have all the storage, where we have all of the internet connection, all of them, they have to go through this cable. And yeah, it's only 1 gigabit uplink. So we are getting like a 24:1 oversubscription rate. So that's what really it means. And you, Laurent, can you explain like just quickly what it means, this 24:1? That seems like even like more numbers there.
Yeah, so if I follow your logic, that's actually meaning a 48:1, right? Because the first 24s should add up. So what it means that on the right-hand side, the third switch, if I have 24 port, 1 gig, right, with 24 clients, well, in order to get to the core on the left, we need to go through a 1 gig line first to the second hop in the middle. So it's already 1 gig for 24, but this gig itself is one of the 24th right there. So it's again another 24:1 oversubscription ratio to the core. So the 1 gig becomes all of a sudden divided by 24 again at the next hop. And we are going to do that at every single hop we will meet. So 24 plus 24, 48:1. It means that 1 gig, 48 gigabits potentially wants to pass through a 1 gig tunnel.
Wow, that looks really bad, you know, like from the 1 gigabit to 1 megabit per second. That doesn't seem like a lot of speed. Like, yeah, so 1 megabit, it will be like really bad even to have like a basic internet connection. So imagine, guys, this university when it was like a 10-story building, like linked together. Like I still remember the ones on the top floor, they couldn't even access to the main resources, was really, really slow. So that's the current issue that we are facing. The first one is to see, like, yeah, really the uplinks, the connectivity between switches. It's not just the access to the devices that are that we need to go over 1 gig. We are still even on the area where the links between switches are just 1 gigabit per second. And as we saw right now, the potentiality, it means that we can get, as a worst case, as a scenario of getting like 1 megabit per second. So just please take this in consideration when you guys see like your network deployments. So what can we do to improve that? I think that there is something that's instead of the daisy chain, we call the star topology. So Laurent, can you introduce a little bit more about this star topology?
Well, I mean, I'm old enough. I knew about the FDDI and token rings in my early days, and all these things are over, right? Because with Ethernet, Ethernet is basically a star technology, a star topology. So why is that? Well, because first we don't want to handle loops with Ethernet, and second, we want to prevent ourselves from going from hop to hop with daisy chain. That's very bad for the reason we just saw. You are dividing every time the capacity of your network. So with a star, every single access switches in that two-tier topology will connect directly to the core. So two-tier networks are usually called such as core and access switches. As you can see, you have 1 gig link for the last access switch to the core and another gig link down to the right access switch. So that's already better because, well, we don't add up oversubscription ratios here, but we still have a pretty bad 24-to-1 connection because we have only 1 gigabit links available, right?
Oh yeah, absolutely. You're right. Like it's better than the 1 megabit per second that we saw in the last slide, but yeah, 41 megabit per second. You guys know, like imagine that you're doing a file transfer or even like watching a 4K movie, you're gonna be like already like not good enough to be able to handle the speed that you deserve. Specifically, you are having a bottleneck, and the bottleneck is not just your network interface, is your network infrastructure, and that's even worse in this case. So what can we do to improve that is we can add some 10 gig coupling. So in this case, for example, we are still gonna use the star topology, and instead of having just 1 uplink with the 10 gig, that will be better because we will reduce the oversubscription. Instead of the 24 to 1 gig, we will go for 24 to 10. So it's gonna be better, but we still have this oversubscription. So when we have oversubscription is that we have a bottleneck. We don't want to have a bottleneck in our network because our networks are our main roads where all the traffic goes through. And now we have SSDs, we have more and more devices connected to it. So we don't want to have any bottleneck at all. So what I can see here is that, okay, we have a 40. So how are we able to achieve these 40 gigabit per second? Can you explain to us, Laurent?
Well, because probably you are a very rich guy, right? Because you just use four 10 gig links between the access layer and the core layer. So it means you are utilizing, maybe 24 port 1 gig switches with 4 10 gig uplinks, and all 4 10 gig uplinks are going straight in connection to the core. So basically you have a line rate installation for your north, south, or east-west traffic, either direction, right? You are line rate. So that's not very usual actually to go under the 1-to-1. 1-to-1 is line rate. 0.6 to 1 is even more than line rate. So yes, you're definitely a rich guy.
Wow, and now that you introduce also this concept of line rate, so what happens inside of a switch? Like, is that the same case? Like, it's line rate, it's the normal thing there?
Well, I mean, at the very beginning, when we saw the very first switches out there in the 90s, after the hubs, some switch implementations were not line rate, right? They were kind of blocking. We were calling such a bad thing a blocking fabric. So at Netgear, we never did that. So as a matter of fact, now those bad things don't exist anymore. So the entire industry, including Netgear, all switches are line rate. It means that as a single switch, the switch will deliver line rate wire speed capacity across all ports, even though you are utilizing the entire traffic in and out, full duplex bi-directional for every port. So the switch fabric is line rate. What is not line rate very often is the uplink capacity. That's what we want to demonstrate here.
Well, great explanation. So that's another takeaway from this explanation. I think that it's as much as you can do, guys. If you're using uplinks, make sure that you use faster technologies, or please use a high power count switch to get like all these connectivity inside the switch, because the switches are line rate, so you don't have any blocking there. So that's the second takeaway that I wanted to highlight. So moving forward, we're gonna start about this multi-gigabit. Is that like multiple gigs, multiple cables, or what exactly it is? So we are gonna cover it right now. So multi-gigabit is all about using the as much as you can your Cat5e cables, because most of them are limited to 1 gigabit per second. And now we're gonna cover what it really means, this multi-gigabit technology. So take this in consideration, that the Cat5e cables that we have are limited to 1 gig. So now we have the uplinks, and we have them using 1 gig. And as we saw, using 1 gig as an uplink, we are really having a bottleneck in our network that we really want to avoid. So why we are not using another cable? So here maybe Laurent, you can help us. Why you will not like run a Cat6a cable where we support 10 gig, and that's gonna be easy?
Yeah, well, I mean, that's easy to say, but in most environments, you know, that's fairly difficult. Think about, you know, I don't know, a school district maybe, or a typical SMB business, or, you know, hospitality, a hospital. I mean, it's very expensive to rewire an installation. You know, when we talk about those switches, we have, you know, $50 per port, $100 per port kind of switch platforms. But when it comes to wiring, you know, it's several hundred and hundreds of dollars that must be spent, you know, in order to rewire, wipe out Cat5e or Cat6 installation for a newer Cat6a or Cat7. So basically, frankly speaking, it never happens. Never. I mean, especially if you have a large installation, it adds up for every single outlet, right? So for that reason, well, we must say that most of the installed base is not capable of 10 gig, period. That's it. You know, 10 gig requires Cat6a. That's a fact. That was how the standard was built. And that's fine for modern data centers. But for the existing installed base, that's a problem. 10 gig is just impossible.
Well, yeah, I can imagine, like, yeah, having to rewire even like our office, like that whole like painful gonna be, like even the process of getting like no network for a few days just because the guys are rewiring, and all like they need even like to shut down all the entire building just to do like kind of this such a big operation. Yeah, I totally agree. Like, yeah, rewiring things is not that easy. That's maybe like, even like if we compare with the current technologies, no, for the internet access, we can see like how the ADSL, like, and getting fiber, it's taking so long, like, because it's not that easy. It's the biggest challenge is getting these new cables there. That's great. So let's see what is the solution. So let's have a look in what are we doing here with this multi-gigabit speeds. So what we can see is that, yeah, the Cat5e cables that we were talking about, now we can run 5 times faster speed. So we can run 1 gig over this Cat5e, 2.5 gig, 5 gig on the Cat5e, and we can keep the limit of Ethernet getting there like till 100 meters. So that's like as the standard. So we don't have to be worried about like if the cable runs well as it is right now. It's 100 meters also like the standard for 1 gig. It will work well for the 5 gigs. So that's a really good news for us. So we can get these 5 times faster networks, and that was the main reason of the title of this webinar, 5 times faster networks using Cat5e cables, so you don't need to rewire your system. So you save the cables and you get 5 times speeds. And as we can see here, Cat6 can start running 10 gig, but in a limited way. It's 55 meters. And as Laurent said, if we really want to run 10 gig, we should go to Cat6a. So that should be like the speed that we are covering. The other thing that maybe you, Laurent, can help us is that, can you explain this to us? What is that about 5 speed? Is like the car speed, or what we are talking here?
Well, I mean, so that's very funny. I mean, multi-gigabit is kind of an industry standard now. We'll see that that's actually IEEE standard now. But the 5 speed is that name that Netgear tried to use in order to indicate those ports capable of 5 different speeds on the same RJ45 jack, right? So fast Ethernet is 1 gigabit is 2, 2.5 and 5, 3 and 4, and 10 gig. So now you have some switch technologies allowing for RJ45, you know, the good old RJ45 ports capable of 5 speed, ranging from fast Ethernet all the way up to 10 gig. But if you don't have Cat6a available to go through your 100 meters or 328 feet run, then you can achieve 5 gig as well. So 5 speed is kind of a neck. I mean, that's the best of the best, right, for today's switch technologies.
Yeah, no, that looks fantastic. So I have like one port that can run 5 different speeds. That's great. And we also have something new in this technology that's called the automatic downshift. So what's the automatic downshift? The automatic downshift is that, yeah, we know that now with the 5 gig and when we go like to a higher speed, we can have like a higher interference. So sometimes what happens is that when I normally plug into like a computer or a storage or a server into my switch, the first thing that happens is that this switch will negotiate with the server or the storage what's the maximum speed. Let's say 10 gig, and it will keep 10 gig all the time. Even if there are like bad connection, it will keep the 10 gig till it disconnects and it reconnects again, maybe with 1 gig. However, we solved that with this automatic downshift. Right now, the network wanna work similar to the wireless network. So with the wireless, when we are close to the access point, we are able to reach the fastest speed. And as soon as we move far away from the access point, we start getting lower and lower speeds. And that's the same case of this automatic downshift. So when there is gonna be like some interference, we are gonna be able to move from the 5 gig to maybe 2.5 gig or even 1 gig if it's needed. But our connection gonna be always stable and gonna be always working on it. So that's the good news of this automatic downshift. And if we move forward, let's look how now we see like this network infrastructure that we were just covering at the beginning with 3 switches, 1 in the core, 2 in the access. So Laurent, can you like go over and explain to us how we are gonna be able to deal with this multi-gig speed and over subscription rate that we just talked about it?
Yeah, obviously. So this time I see that, you know, you used to have 4 green lines before. So you were using, you know, 4 10 gig links, provided you have, obviously now we know Cat6a available across your building, for instance. Now with multi-gig, if we don't have Cat6a, say, let's say you have good old Cat5e, you know, for the past 30 years installed there, well, with your Cat5e, you can now maybe get a switch with 4 multi-gig ports, and those 4 multi-gigabit Ethernet ports will connect at 5 gig to the core. So 5 gig times 4, that's 20, right? So in that diagram, I see that I have 20 gig of capacity in aggregation to my core. And well, if I still use a 24-port switch, meaning 24 port times 1 gig switch, then my oversubscription is better, but it's still a little bit oversubscribed here because I have 24 gig against 20 output, so that's a 1.2 to 1. 1.2 to 1 oversubscription, which is actually quite good if we remember that before, without multi-gig through Cat5e, we were actually talking about, a giant bottleneck. Now, 1.2 to 1, if all networks in the world would bear a 1.2 to 1 oversubscription, I think that most customers in this world would be happy.
Yeah, I think that 24 to 1, it's even like the bad, like a kind of a high standard when we compare what we see on the field. I think that we can see like 100 to 1 as maybe as an average. And also now we are going to cover, okay, that's the uplinks, but also as we saw, like in the network itself, in the systems itself, gigabit is not fast enough. So what we can see is that the ecosystem is growing. So it's not only like the switch that needs to be multi-gig or 10 gig enabled. We also have different devices that needs to be 10 gig and multi-gig enabled. However, before we move forward, I would like to talk about a little bit more about the road to this multi-gig and how like all these 100 meg, 1 gig, 2.5 gig started to be there. So maybe that would be like a slide for you, Laurent, to cover.
Hey, thank you. So as you can see, this slide is not Netgear, right? We have this slide from our alliances, and Netgear is part of this N-based alliance, obviously, that invented the multi-gig technology. That was a consortium of several industry vendors, working together to go beyond 1 gig on existing installed cabling. And also the Ethernet Alliance, the Ethernet Alliance is feeding the IEEE, proposing new standards so that they got ratified. So both Ethernet Alliance and the N-based Alliance, they published last year, actually, this latest roadmap. This is the road to the 10 terabits mountains. So now, Xavier, I know that I'm too old. I will never see in my lifetime probably 10 terabits everywhere at the access or the core in SMB networks, But
you are young, Laurent. You're still gonna be no terabytes. You're gonna be petabytes or something like this. No worries.
So I mean, but we know it will come at some point. But yes, I mean the point here is to say that the 1 gig is very old. The Ethernet Alliance pushed the 1 gig project to the IEEE back in '98, as we can see here. Now 10 gig was also pushed out in 2002, and it was ratified 1 year later by the IEEE. 2.5 gig and 5 gig are just going in the middle because the industry needs it. First for wireless, because wave 2, 3x3 and 4x4 multi-user MIMO 11AC access points can move way more than 2 gigs of wireless throughput, right? So as a matter of fact, the wireless made it start, and now, as you just said, more and more devices will come because at some point, analysts such as Dero, already forecast that the multi-gigabit Ethernet technology, 2.5 and 5 gig, would ultimately replace 1 gig ports in most equipments, including devices, network devices, and switches. So by 2021, in 4 years from now, we should see already more than 25% of that giant market switching to multi-gig instead of 1 gig ports. But yes, we see that after that, 2.5 and 5 gig might become the speed, the reference for the access layer. For the aggregation and the core, we'll see new technologies coming with 25 gig, most likely in between 10 and 40. So that's just the beginning.
Yeah, if I look this road, I am quite scary about, Laurent. It means that it seems that we are still in this 1998 and we haven't moved forward. We still need to go over like this one, even like, so that's, yeah, I think that now is the time to move to the next step. Totally agree. So if we look now the ecosystem, so as we said, like, yeah, we already know that we have switches, and later on we're going to cover some of these products that we have, 10 gig and multi-gig built it in. However, it's just switches that we have that supports multi-gig? No, it's not. So we have also a bunch of areas about like this multi-gig to the desktop. As we saw at the beginning, right now, when we open a computer, the bottleneck is on our network. So that means that not just us, that we are seeing that. It's not just Netgear, it's also the whole industry that it's seeing this. So we can see workstations with these 10 gig and multi-gig NIC cards. We can see PCIe NIC cards that now becomes really affordable. The price points of these faster speeds, multi-gig, 10 gig, just dropped to the price range of $100 each for a NIC card. So it's getting affordable even to move this technology, not just to the switch side, also to the desktop. And that means that the entire industry, it's gonna be like, imagine getting your laptops and your workstations connected to multi-gig and to the 10 gig. In this case, yeah, the need of even like the uplink is gonna be like these multiple 10 gigs speeds or even faster to not have like a oversubscription rate. But more about that is we have iMac Pro like shipping this December with 10 gig and multi-gig built it in. So product like from Apple that will have this 10 gig and multi-gig built it in network card that it's going to be connected to a switch that needs to be 10 gig multi-gig and mobile workstations. So, you know, guys, if you look your right now your desktop or your laptop, you're going to see that you have less external ports like USBs or something like this. However, most of them, they've been replaced for a faster connectivity like USB-C or other technologies. So in this case, what we are seeing is that USB-Cs to 10 gig or USB-Cs to multi-gig, so is like even your laptop gonna be able to have as a wired speed or with your docking station, this multi-gig or 10 gig speed when it's working. And moreover, on the enterprise side, not only desktops or not only computers or switches, also the wireless routers and the wireless access points, as Laurent commented, that was one of the first ones to get like that they got like this multi-gig technology, because if the wireless is over 1 gig, if we're using 1 gigabit to connect to the switch, well, we have an issue. It's not gonna be fast at all. We have storage devices like our some NAS that works in the 10 gig and multi-gig, and even like some motherboards are getting there with built-in 10 gig multi-gig and also Thunderbolt ports. So as you guys can see, the ecosystem, it's quite rich. Not only even like to talk switch to switch, also like to consider like devices connected directly to the switch itself. So let's move forward and have a quick look in what kind of Netgear products do we have. So here, I will let you, Laurent, to introduce the product line, because you were the first one to introduce a multi-gig switch with the M4200. So I think that that's a good way to start with.
Oh, thank you, thank you. So as you can see on the right hand side, the M42 was the first switch on the market actually 2 years ago with 8 ports of multi-gig. So you have different flavors, different kinds, you know. So this particular switch capacity was 6 ports of 1 gig and 2.5 gig, and 2 ports of 1 gig, 2.5, and 5 gig. So that was a 8-port switch, really dedicated to, you know, these Wave 2 3x3 and 4x4 access points that can deliver more than 2 gigs of wireless throughput. So the 4200 switch was out, you know, in conjunction with the Netgear WAC740, which was the first Netgear Wave 2 11AC access points out there at that time. Now, 2 years after, you can see that Netgear is one of the vendors who invest a lot in the multi-gig technology. Now we are ranging all the way up from unmanaged on the left. So you can see that, I mean, unmanaged switches, that's unbelievable. unmanaged switches with 10 gig and multi-gig capacity, shipping now with the XS505 and 508M. We have unmanaged switches, another group, with this time 8 ports of 1 gig and 10 gig slash multi-gig slash 5-speed port uplinks available. So that's 8 plus 2, great to minimize, the oversubscription so that you have a line rate installation of a gigabit switch thanks to these multi-gig and 10 gig uplinks. The GS110s MX are, in the unmanaged space, but there is also a smart managed plus version, much more intelligent, with software on board to manage quality of service and VLANs. And next is the MS510 family, after unmanaged, after smart managed plus. This is the smart managed pro category. This time we have 8 plus 2 switch platforms with 8 ports. You have half of the 8-port count capable of 1 gig, the other half capable of 2.5 and 5 gig, and then finally 2 10 gig uplinks. One of them is multi-gig 5-speed copper. So the smart managed pro switches are a little bit more advanced. They are really dedicated to SMB use organizations who want the most out of their platforms with spanning tree, SNMP, access control, so a fully featured web GUI on board. The 4200 is still, to date, the only one fully managed platform with the CLI. So that's a big change from a fully managed switch offering. Now, Netgear, we are on the market from unmanaged all the way up to fully managed, and from unmanaged to plus to fully managed with a collection of access and aggregation switches, ranging from access switches with 10 gig or multi-gig uplinks to the full 10 gig multi-gig platforms.
Wow, that looks impressive. Yeah, to have already 7 products in this 10 gig multi-gig. That means that we can build like any SMB network using this 10 gig and multi-gig technology. But I would like to know a little bit more, Laurent, about this fantastic MS500 family. So can you just give us a little bit more detail on them?
Sure. So the MS510s are very cool products. Actually, they are desktop, so the form factor is not too big. They are as good in the rack with the rack mount kit or outside of the rack, thanks to some clever mounting options. And as you can see, they come with, basically 8 ports for the access and 10 gig uplinks, 2 ports for 10 gigs. And the 8 ports are, a collection of 1 gig, 2.5 and 5 gig ports. So that's really future-proof platforms for devices of today and maybe devices of tomorrow, but also the 10 gig uplinks capable of multi-gig can accommodate either a weird Cat6a 10 gig capable wiring or a good old Cat5e, and this time we will then have a 5 gig uplink capability. So MS510s is the Netgear first array in the Smart Managed Pro land, and as you can see, we have a PoE version with a whole lot of power. It's 180 watts actually, and a non-PoE version. The software, as I just said, is really capable. It's fully featured with the static wiring, both for IPv4 and IPv6, advanced VLANs and security and spanning tree and SNMP. So that's really good for organizations who want the most of their little access switch infrastructure.
Wow, they look fantastic, honestly. And having the PoE option to power any of these multi-gig, that's also like a good point. So you can run PoE over like 5 gig, 2.5 gig, Laurent?
Absolutely, and that's the case from the beginning, with N-base-T back in the old days. So now that's a standard with 802.3bz, and yes, these RG45 ports can deliver PoE plus. At this time here, it's 30 watts, up to 30 watts per port, either at fast Ethernet speeds or 1 gig or 2.5 or 5 gig.
Wow, so 5 gig and PoE plus. That sounds fantastic. So mainly like access points, or you can see that, and even like IP cameras. It should be like a good application for them. They need bandwidth and they need power.
Hi, sorry to interrupt. We have a quick question from Lynn. She's asking, why only an 8-port multi-gig switch? Is it not valid to have a 12 to 24-port multi-gig?
Well, I can answer that one, and later on give it to you, Laurent. You can add it. So it's coming. That's what we can say, and it's not gonna take long to have it. So that's the fastest answer. It's about priorities in terms of like which were like the products that we need to deliver first, and we started with the 5-port, 8-port. But yeah, we're expanding the range, and soon we're gonna have 24-port and 12-port and 24-port.
So let me just complement that. That's a good answer. And at Netgear, you know, we really strive to deliver 10 gigabits and now multi-gigabit speeds to the masses. You know, driving the cost down. And you know, we had to wait until we got a cost-effective platforms, because it's lean, right? Lean, I'm pretty sure you would agree, customers are not really in that space, SMB space, not ready to pay several $1,000s for a 24-port 2.5 gig switch. It's not true. So you have big enterprise switches out there with this kind of cost, but you know, that's really reserved for ultra high-end enterprise wave 2 access points deployments, let's say. Now, as Xavier just said, our goal at Netgear is really to bring higher port counts, obviously, as you just said, 24 and maybe in the future 48, but you know, we want to keep that pricing affordable enough for the SMB. That's why we have to wait for the right time until that technology can be delivered at the right price point.
Well, great. So let's continue with the other products that we have on the multi-gig. So now we're going to cover the 10 gig multi-gig unmanaged switches. So here, what we can see is the XS505M and XS508M. So these are unmanaged switches. So what does it mean is that we don't have a configuration menu for them. So they are plug and play as all the rest, even like when you have a Plus or a Pro, all of them are plug and play. And in this case, you guys, you can see the compact size, also the 500 case. They are desktop or rack mount. And the first 4 ports in the XS505M are copper ports with 10 gig, 5 gig, with this 5-speed support, 10 gig, 5 gig, 2.5 gig, 1 gig, and 100 meg. And we have the fiber one, SFP Plus, because we still see some devices that still require fiber. And we have the fiber support with the SFP Plus, with the 10 gig and the 1 gig. And the XS508M, similar form factor. The difference is that we have 8-port multi-gig and 10 gig and multi-gig, and we have this combo port where we have SFP Plus, that's fiber port with the 10 gig or 1 gig support. So that's for the unmanaged space. And if we look like the new GS110 series, where we have the unmanaged and the Plus version. So as you guys, you can see, that's a fantastic switch in terms of the oversubscription rate. It's 8-port. So imagine you can have 8-port and you can have 1 10 gig uplink. So you will not have oversubscription. So you're gonna be able to like link all of them like with like full line rate here. And you also have an extra port that maybe you can use it even like, for example, to have like a secondary like device that runs 2.5 gig or 5 gig. And in the GS110 EMX, in the Plus version, this supports basic VLANs and QoS and static LAC and LACP to be able even to aggregate these 2 ports, and you can have a 20 gigabit per second uplink to your core switch. And also they are silent switches, so they don't have any fan, so you can set it up on your desktop. And you also can rack mount it, so even that they are really small, switches and the form factor is small, you can rack mount them into like, yeah, in a rack environment. So that's like introduction about our product line. As you can see, 7 products with this 10 gig and multi-gig space to allow you guys to start deploying this technology that allows you to save the cables, get the maximum speed of these cables, and reduce the oversubscription of those. So let's go a little bit more into the details, and let's have like a few examples how we can fit all of them together with the network infrastructure. So the first example is gonna be about deploying the switch as a desktop switch with the 10 gig uplink. So in this case, I think that the MS510s are a really good option. So Laurent, can you just explain to us what kind of a use case we can build?
Sure. So, I mean, at the very beginning, we said, let's start with those small port counts because we really could achieve fantastic price points. You know, that's something we must highlight right now. The MS510s and the MS510T XPP retail, if I can speak like that, for $300 or $449, which is very low. And basically, before the big fat 24 and 48 port switches, such 8+2 switches are very often used as a collapsed core. So as a single switch for a small branch, for instance, or a small and nice but performant work group. So in that case, even if I don't need multi-gig right now, well, I can still use the 8 ports, PoE or not, for my devices, my phones, my access points, my storage, or my local server, and profit from 10 gig connectivity all the way to my servers and storage, for instance. Of course, we can use those uplinks to go up in aggregation to the core, but as a single switch, that's the very first use case for us. You have a very capable collapsed core, capable of 1 gig and 10 gig today, and tomorrow capable of 2.5 and 5 gig speeds when the new devices will come in. So that's what we call a future-proof installation.
Wow, that looks really good. Like one switch and you get it all. So that's the only switch that you really need for SMB, and you have everything there. We will like to also highlight another use case that's about using it more as a desktop switch with a 10 gig uplinks to a core, as we saw, like with the access and the core layer for the switching. So here, Laurent, what we can do in this case?
So in that case, you know, that's for sure now quite used often with wireless APs, because I saw a question on the chat box from Gary, what kind of PoE devices, you know, are compatible with multi-gig today? I think we can answer, you know, basically wireless access points, you know, so Wave 2, 802.11ac wireless access points, because with these 3x3 and 4x4 radio solutions, they can move more than 2 gigs of wireless throughput, so they ship with multi-gig ports instead of 1 gig ports. So in that case, you will then be able to really leverage your Wave 2 installation, and the switch should definitely not be your bottleneck in a Wave 2 installation. But back to the point on that particular use case, we know that, you know, Wave 2 access points are high-end, and many SMB customers don't have Wave 2 AC APs yet. So in that case, such a MS510 switch can be used today with 1 gig APs, obviously, and the 10 gig uplink is really appreciated, right? Because then you don't have a bottleneck. Here it's 8 ports and 1 gig to a 10 gig uplink. That's actually less than 1-to-1 line rate, so that's even better. But tomorrow, future-proof installation, I will be able to swap my access points and replace them with Wave 2 APs with multi-gig, and my platform is future-proof enough.
And you also have redundant uplinks to the core.
Well, yeah, so if you are very advanced, you can for sure, you can use copper and fiber in order to have different paths and to survive if anything bad goes on one link. You're right.
Well, you know, Wi-Fi, it's a basic need right now, Laurent. So I will say everybody should have like redundancy everywhere.
Okay, I take it back. So you really must do it. You're right.
It's good. So, and the last use case that we just want to highlight to you guys is about using, these 10 gig uplinks and access and core layers that we saw. So in this case, we have a combination with our unmanaged switches. So that's like for the ones that you don't want to spend time configuring it. This just like, as I said, unmanaged switches, plug and play. You get like a fastest, like a really fast network with the gigabit to the desktop with some devices that can run the multi-gig speed, but with the 10 gigs to this core switch where you have like 8 ports, 10 gig multi-gig to run like the storage or the other switches. And that's the good news, is that this kind of a network infrastructure, the price points that we were talking about just to do it like 3-4 years ago would be like around the $10,000. Now we are around the $1,000 to do all this infrastructure. So we are talking about like 10 times cheaper. So that's what we really want also to highlight, is that this technology, the 10 gig and multi-gig, is getting affordable to the point that, it's getting into the masses to be able to deploy this multi-gig and these 10 gig speeds. So that was what we really want to share with you guys in terms of these new switches, and also how to deploy these faster networks that we really want to be focused on. And if you don't mind, we can start now the Q&A session.
All right, thank you so much for that presentation. We have a question from Edward. He's asking, can you limit port speed on the managed switches?
Oh, that's a nice question, Edward. Thank you, Rachel. So, Laurent speaking. Maybe I can start, David, if you don't mind. So the answer is yes. And there's multiple answers for that. So we won't have time to go over all the techniques that you can use on managed switches. But roughly, we call a managed switch when there is a software in it. So plus switches, smart managed plus switches can do it. Smart managed pro switches can do it, and fully managed switches obviously can do it all at well. As you, the short answer is that you will either modify the auto negotiation on that port to block it, you know, at 5 or 2.5 and 1. But usually you want to be, you want to do more than that, so you can be even more granular. With higher grade switches, you can use access control and apply either QoS, diff serve strategies based on the streams you want, or based on the devices or the IP addresses or MAC addresses. So a lot of things are possible in order to, you know, build the infrastructure you want with the speeds you want. So the answer is yes, definitely. So the question was about node control, and that's right. Node control is a perfect example when you want to, you know, set up some policies in order to maybe back up your internet connectivity and delivering less bandwidth to certain nodes. I see another question. Maybe that's for you, Xabi. Do we have a model with 8 ports capable of 1, 2.5, and 5 gigs?
Yeah, well, that's a good one, too. So yeah, we do have one model, and honestly, depending on the port configuration that you are looking for, you also can. We have 3 products. So the first one is the XS508M, where you have these 8 ports, and the ports are 10 gig and multi-gig. So it means it's even better. You have 10 gig, 5 gig, 2.5 gig, and 1 gig, and moreover, you can also look, depending on the port combination that you're looking for, you can look the MS510s, so where you have the 4 gig and 2.5 gig and 5 gig, 2.5 gig and 1 gig, and the 10 gig. So honestly, yeah, depending on the port configuration, you can have like even 3 options.
All right, we're running low on time. Any questions you guys have, don't worry. We will get to them by email. And if anyone else has additional questions, feel free to email us. Our email will be attached to the follow-up email. Thank you so much for joining us this quarter. And this is our last webinar for the quarter. So everyone have a happy holidays. Thank you.
Thank you, everyone.
Yeah, thank you, everybody. Have a great holidays for all of you. See you in the next year with more webinars.